Good morning students. Today we are going to discuss about flame. What is flame and the different parts of the flame and the next fuel efficiency, and also we are going to discuss about caloric value. So let's start.
Today first we start with flame. In some combustion there will be both flame and light formed. Let's complete a table. Here we take different types of materials like candle, magnesium, camphor, kerosene stove and charcoal. Let's look which form will make flame and does not form flame. When we burn candle, magnesium, camphor, kerosene stove, it will form flame, and in the case of charcoal, it does not form flame. How is this flame formed? Let's analyze this through an activity. Here we take a candle and light it and introduce a glass tube to the dark zone of the candle. Then we also try to fire the other side of the glass tube. At that time, when we introduce a fire at the other side of the glass tube, it will burn. How is this happened here? Because the wax of the candle melted and it will go forward. The wax melted and vaporize and it go forward and it's passed through the glass tube. When we show a matchstick flame, it will burn. That is, substance which vaporize on burning gives flame. In the case of charcoal, it does not vaporize on burning, so no flame is produced. So the substance which vaporizes on burning, it will gives flame. Substance which does not vaporize on burning will not produce flame. Next we are going to discuss about flame and the different zones of the flame. Look at this picture. The flame has 3 zones: dark zone, luminous zone, non-luminous zone. The innermost zone of a flame is dark zone. It will be black in color. It's least hot because no oxygen available there, so no combustion takes place. The middle zone is luminous zone. It's yellow in color. There will be moderately hot because of the limited oxygen availability, so it's partially combustible. And the outermost layer is non-luminous layer. It's blue in color. It will be the hottest part of a flame. There will be plenty of oxygen available, so the complete combustion takes place. Next, fuel efficiency. The amount of heat energy produced on complete combustion of 1 kg of a fuel is called its calorific value. The calorific value of a fuel is expressed in a unit called kilojoule per kilogram. Calorific value of some fuels are given the table. The hydrogen is the most efficient fuel in the case of its calorific value. The next is the characteristics of good fuels. When a fuel become very good, it should be readily available. The next one, it should be cheap. It burns easily in air. It should burn at a moderate rate. Then it should have large calorific value. It should not leave behind any undesirable substance. It should be easy to store. And the last one, it should have low ignition temperature. Next, burning of fuels leads to harmful product. The increasing fuel consumption has harmful effect on the environment. The carbon fuels like wood, coal, petroleum release unburnt carbon particles. It creates respiratory problems. The next, incomplete combustion of these fuels give carbon monoxide gas. It is a very poisonous gas. It is dangerous to burn coal in closed room. The carbon monoxide gas produced can kill persons sleeping in that room. The next, combustion is the most fuel release carbon dioxide in the environment. Increased concentration of carbon dioxide in the air is believed to cause global warming. The CO2 release leads to the global warming. And the petrol engine gives off oxides of nitrogen and sulfur. It will be leads to acid rain. So, our chapter combustion and flame completed with this.
In this class, we discussed about flame and different parts of the flame. We did different activities and also we discussed about the efficiency of fuels and caloric value. With this, the chapter is completed. So, all should read the textbook, write the notes and study well. Thank you.